Printed Solid's next-gen safety enclosure. They're lightweight, but still really durable. They come in a couple different sizes. There's lots of room inside for your printer. They even come with a hookup, so you can add a filter if you want to. But it would be nice if there was just a little bit more automation to this config. Hello everyone, Chris here. Printed Solid sent me over this enclosure a couple of months ago, along with a BOFA Print Pro One, and I've been using it quite a bit, at least a couple times a week. I use it with my Prusa Mark III, I print a lot of ASA, ABS, even PETG if the walls on the print are really thin. That can help it succeed. Now these enclosures are designed as a passive enclosure, so there's no heat inside. And it does a really good job keeping the enclosure ventilated, so it sets around 32 to 34 C when your bed is running around 100 or 110. And the parts come out really well. And just as an example, here's a fan duct for one of my tool changer heads. This is Prusa Mint ASA. If you don't have an enclosure, a lot of times these can pull or break loose from the print surface. You can see where it was printed on the print surface here. It's very smooth, no pulling at all, and the layers are very consistent. And when printing a little higher material like ASA or ABS, an enclosure sometimes is almost mandatory dependent on the part because you will get layer separation. And as I mentioned with PETG, this is an extremely thin part. If you're printing in open air or there is a draft, sometimes you'll get splits in here where the layers won't adhere to one another. You don't necessarily need an enclosure for PETG, but depending on the part, it might be helpful. So for most jobs in the hobby-based printer market as it is, this enclosure does a fine job at around that 32C mark. But it would be really nice to have some add-ons to this enclosure. Meaning I'd like to add active heat. It definitely needs a little bit more light in there. We can add OctoPrint so we can control a few different things. There's a whole list of things that I'd like to add to this unit. But this is going to take a lot of time. So this video is going to be two parts. We're going to build up the enclosure so it's automated, we can control it from OctoPrint, and we're just going to check out a lot of cool different items along the way. So let's start with the easy fix. Now if you work with a 3D printing enclosure, you do a lot of prints inside one, the first thing that you notice that you need to address is how much light is inside. There's a lot of different things with 3D printing. When you're working with different materials, you need to be able to see the first layer really well as how the print is turning out. So this enclosure really needs a lot more light. And for this project, I have elected to go with this LED strip. They're very affordable. They are 12 volt. And for this whole project, I'm going to go with 12 volt as much as I can. Now you can go with 24 volt. You could even use the PSU on your printer. Any voltage, depending on the printer that you have. But I'm going to go with my own power source and then step it down as needed for different items. So we'll try to stick to 12 volt as much as possible. But these strips, again, very affordable. They come with double-sided tape that you can attach them with, and they also have some brackets you can use. Now I'm not sure how the tape's going to do in the heat, but we'll probably start with this and then move through the brackets if we need to. So the wiring on this particular strip, go by the directions for your light, of course. But on this one, I'm just going to attach one of the white leads to the yellow. I'm going to put that on negative, and then this side, the standalone one, will be positive. This light, you can do it either way, it doesn't really matter, but that's how I'm going to hook it up. So for now, I'm just going to put my tape on the back, and I'm just going to stick it on the top of the enclosure. I'm going to have all the wires run to the right. That's just because of how I use the enclosure and where it is on the stand that I have, but I'm going to try to park pretty much everything over here on the right side, so we'll have them run out the right. But I'll just stick it right in front of my spool holder mounts. And for the wiring for that plug, the light actually comes with a little bit of wire so you can extend it. I'm just going to splice in and solder this extra wire and then put some heat shrink on it. And to run the wire, I just drilled a 5mm hole. That's not going to hurt us very much. We'll have to drill a few holes here. But now we have to worry about power management. So at this point, I'm not exactly sure how many devices we're going to add to this enclosure. A few. But I do want to stick with 12 volt, like I said before. So I elected to get these two power strips. There's 5 different lugs on each, and I'm going to divide them up. One is going to be positive, one is going to be negative. So I'll have one input, and then I'll have 4 outputs if I choose to use them. which we're going to use a couple. So I'm going to mount these to the enclosure, add these strips so that all of them are connected, and then hook them up to our power input. For our power input, I'm just using this random AC/DC adapter. It came with some printer kit a long time ago. It's 12 volt, 6 amp. It's going to be more than enough than I need to run all the stuff on this enclosure. It just has a standard barrel connector, and it also does have a switch. And to get that barrel connector over to my power strips, I'm just going to use this pigtail right here that will accept that connector. So I'm going to start by mounting these strips somewhere in here. I kind of want them to be back towards this corner. That way I can plug in the power somewhere back here and it'll be out of the way. But remember, I am going to do two side by side, so we need just a little bit of room. M3 by 12 millimeter screws are more than long enough to put that on this enclosure. I did put a washer on them. Those holes are just a little bit bigger. But I'm just going to mount both of those somewhere in this area. So we've got those two mounted. Again, I'm going to feed it with this pigtail. So I need to cut around 11 millimeter hole. I'm going to put it right in here. And there are vents on the printed solid enclosures. I'll probably just route it out one of these rather than cut a new hole. But then I'm going to park it on these two lugs. So I have a positive and a negative. So I've crimped on some connectors to the pigtail for the feed. Then we've got these blade connectors. So all of them will be connected, so they'll be the same. We can use all five. I'm going to put the negative one here on the outside. And then the positive one over here. And then we can hook up our input feed accordingly. And then the first device, our light here, I'm just going to set it in this next set of lugs. I'm not sure about controlling the light. I thought about it, maybe putting it on a relay, controlling it with OctoPrint or something like that, but I might just want it on all the time. There is a switch on the light. I can turn it off, or I can just turn off the whole enclosure. We'll see how that goes. For now, I just want to turn it on so I can start using it. So we've got our lights hooked up. We're going to worry about wire management at the end of this. We can plug in our power adapter, then we'll kick the switch on, and we have light. Already, this is so much better than not having any light. We're going to be able to see things much easier. So that was the easy part. Now we need to address OctoPrint. So we're going to need a Raspberry Pi, and we're going to need a sensor for this unit because I want to be able to tell OctoPrint what temperature it is inside so we can make some decisions on what to do next. So let's work on getting that set up. So here's where we're going to start. We have a Raspberry Pi 3B Plus. That should be more than enough to do what we're going to do. I did purchase this header. It makes it a whole lot easier to use the GPIO pins. It's just a terminal strip for each pin. You can use the really small ferrules with it. So this is going to make a lot cleaner install. And then I downloaded this case from Thingiverse. I'll leave a link. This is a really popular one. I like to use it in a lot of different scenarios, but it has mounting tabs that we can mount it to the side of the enclosure. Remember, these enclosures do have metal-faced foam panels on them. That's not plastic, so you don't want anything to conduct. So having the pins exposed or anything like that on the back of your Raspberry Pi to that enclosure is not a good thing. And to power our Raspberry Pi, remember our enclosure is currently 12 volt. That's the adapter we're using. I'm going to use this buck converter to get it down to the 5 volt that we need for the Pi. Again, Thingiverse, there's a little mount. We're going to use that to put it on the side of the enclosure. And then I just clipped a micro USB cable so I can still use that Pi interface. And we'll install all of this. So our header, it's clearly marked. All the power for these GPIO pins, the 5 volt and 3 volt pins, are down here. And they've marked those red, so it's really easy to put it on. Just slide it on just like this. And this kit did come with some standoffs, some plastic standoffs as well. I'm going to use those as a spacer so I can put the screw all the way through the header and the board and then mount it to the case. I've got this all fixed up. I just used some M3x6s down here for this case. Now we can go ahead and put it on the enclosure, but I do want to load my SD card first because they can be kind of a pain after they've been mounted. And I think I'm going to mount the Raspberry Pi somewhere up in here, because I want to keep it out of the way of the other things. Also, the temp sensor is going to mount on these pins, and I'm going to put it on the far other corner so that we can take readings from the top corner of the enclosure. I'm also going to put my thermostat kind of in that area, but I'll show you more about that when we get into that section. So here will be good. Probably just like some M3x12 hardware to put this on here. So we've got our Pi on. Now we need to worry about getting some power to it. And for our buck converter, with this mount, the converter actually just snaps in here. It's got little pegs that go in the holes on the PCB. And there's enough clearance where you can use some hardware in the two holes on that mount. So after you mount it, it should just snap on. And that's actually a really nice fit. It's nice and tight, shouldn't go anywhere. Now, we don't want to plug in the Pi to the converter yet, because I really have no idea what voltage this thing is running at. We don't want to run the Pi right out of the gate. So we need to plug in the input voltage. Again, we're using 12 volt for this. So we'll run it over to our power strips that we installed. We'll get the input turned on, then we'll adjust this with a meter. So here's the power input side for the buck converter. And those of you that are worried about the wire management for this build, I do have some of these 3D printed zip tie downs that I'm going to use double-sided tape and get all this lined up once we know all the links and everything that's going to be installed. So we will address that. So now let's get our DC adapter plugged back in, and then we're going to see what the output on that buck converter is currently, because we only need 5 volts for that Pi. So on this one, we're currently at a 586. Raspberry Pi recommends 5.1, so this is just a bit high. So we need to adjust it. With your super tiny screwdriver, there's a brass screw right here. It depends on the converter you get, left or right, up or down, so you just got to play with it. But we'll turn this one down a little bit. And there we got it to 5.1. Mine was actually turn it left, and it goes down. So we should be in good shape. We can plug in the Pi. And our Raspberry Pi is up. Now I am assuming that you've already installed OctoPrint if you're tackling something like this. I'm just going to run through it. This is a fresh install. I am going to add some plugins. I'll show you all that stuff. So we've got OctoPrint installed. It's up to the newest version, currently on 1.6.1. Something I did want to mention, I've done this before where I've run Raspberry Pis on buck converters. Make sure you're not getting any warnings up here about power, because that's going to throttle the processor if it's not on the right voltage. Remember, we have the buck converter, we have cables in play here, so there might be voltage loss. If you're seeing something like that, go back and measure the voltage at the Pi. Make sure it's set correctly. Just something to look out for. Now we're going to need a plugin. So let's go to Settings, Plugin Manager, and up here to Get More. And there's a really nice Enclosure plugin out here. So we'll just search for Enclosure. OctoPrint Enclosure. Let's go ahead and install it. After it's installed, we'll go back to Settings, Enclosure plugin. Now basically what this plugin allows you to do is set inputs and outputs so we can take in information and then control other things going out based on that information. And the first thing that we want to know about is how hot is it inside our enclosure. So we're going to add an input. We're just going to name it Enclosure Temp, and then we're going to tick Temperature Sensor. And then there's a few sensors that are supported. Definitely go out here and take a look at the GitHub page in this attention message. Vitor has done a great job on this plugin. He was taking a break. I'm not sure where he's at with the plugin right now. He's still working on it, but there's a lot of good stuff here already. What we're interested in right now is the sensor section and the different kinds of sensors you can use. Now, in my opinion, the one-wire sensors are the easiest. So that's what we're going to use, and they're pretty accurate. We're going to be using a DS18B20. And there's very little configuration you have to do here, but we do have to install a resistor, anywhere from a 4.7K to a 10K for the data pin. And because this is a one-wire, it is supported directly on pin number 4 of the GPIO header, so that's what we're going to use. We do have to get into the terminal and make a few changes. So let's do that first, and then we'll take a look at the sensor. So I'll just jump over to PuTTY, and we want to change directory into /boot. You can take a look in there, but we need to edit config.txt. So sudo nano config.txt. And we're going to go all the way to the bottom, and we're going to add in dt overlay equals w1-gpio. That will allow us to support the one-wire sensor. So that's all we have to do here. We'll Control X, Y, and enter to save, and reboot. And when we come back up, we can do some mod probe commands to test this out. We haven't plugged it in yet, but this is going to be the process. So we're going to mod probe that W-GPIO, and then also W1-therm, THERM. And then we'll change directory into /sys, /bus, /W1, /devices. You can take a look in here. Here's where your devices will be listed. But now let's jump over to the sensor, and let me show you how to get that set up. And remember, I told you we're going to need a resistor for these. You want it from the power leg over to the data pin, which is the center pin. So power, center pin is data, other side is ground. It can be anywhere from a 4.7K to a 10K. I elected to just build everything on this PCB. One, it's easier to install components and get them to stay put, and it's also easier to handle inside the enclosure, easier to tie it down to something. So that's how you're going to set up your sensor. So I just made up Dupont connectors, one for each side. I've got a wire loom here, and then I've got ferrules on the other end of that. That will go into our Pi header. And I'm just going to run them on the top of the enclosure with these printed pieces, again, double-sided tape. And then we can just zip tie the sensor with the PCB onto one of those. Hopefully the tape that I have is good enough to stand up to the temperatures that we're going to have inside here. And it's really hard for me to show the inside of the enclosure with the camera, so I just snapped a picture with my phone. I just have it zip tied up there to the top. And wiring it up is pretty straightforward. On the bottom row down here, the first pin is 3.3 volts, and that's what we want for this sensor. That 3.3 volt is actually pin number 1. Then 5 pins in, that's actually the number 9 pin. That's a ground pin you can use. And then we want to use the GPIO 4 pin. Now, don't mistake the GPIO number for the pin number. We're talking physical pin numbers here. So the GPIO 4 pin is actually physical pin 7. It's the 4th pin in on the bottom row. And remember, I showed you that's the pin we want to use for these one-wire sensors. It defaults to this pin. And that's all we need for this sensor. Now let's jump back to the terminal and check it out. Now if you do that ls command again in this directory, you're going to have a serial number right here. I believe all of these sensors start with a 28, but this number is important. And I'm going to go ahead and copy it, because the plugin does use this serial number. If you wanted to use multiple sensors, that's how you would tell them apart. But we can change directory into that number. If you do an ls in there, it's going to show you some stuff about the device, how it's using it. But this W1_slave, you can cat that, and that'll give you all the stats about that sensor. Down here, this is telling us it's reading 25.5C. And since we know it's working, we can jump back to the plugin, settings, enclosure plugin, back to adding inputs. Remember, temp sensor. We'll select our DS18B20. The sensor pin defaults to 4, but we'll go ahead and punch it in. Then we'll paste in that serial number that we copied from the terminal. And you can switch it to Fahrenheit if you like. Most of us are pretty used to C by now. And we'll let it show that temp in the nav bar. So let's go ahead and save it. And then up here, we have our enclosure temp input, 25.5C. And that's going to be pretty important. We're going to use this to make a lot of different things happen going forward. So now we're starting to get somewhere. We've got the power sorted out, we've got a Raspberry Pi on, OctoPrint, and we have an active sensor that we can use to make decisions on how to control certain things on the enclosure. But now we need to talk about heat. Remember, the point of an enclosure is not to tighten it up and get it as closed as possible so you can keep all the heat in. That can be somewhat dangerous in certain scenarios. It's to be consistent. That's what you want out of one of these setups. And this one has vents on it so that it regulates correctly so it doesn't affect your print, but it keeps the temperature in a good range. And remember, I'm using a Prusa Mark III, and if you're used to a RepRap style 3D printer, it probably has printed parts on it, and those are made out of plastic. So now we need to figure out how to get a heater installed, and then figure out what is the optimum temperature for this heater. And you could just look it up on the internet, but that's no fun. We need to test it. So let's start by taking a look at the heater and the thermostat that I'm going to use for this. So here's what we're dealing with for our testing, our heater and our thermostat for our enclosure. This is a PTC fan heater. It is 120 volts, so we have to deal with that. It's 150 watts. It's not a huge heater, but it's more than enough for this size of enclosure and the temperatures that we want to get to. And then we have a KT11 thermostat. This is just a panel mount thermostat that we can hook up in line to our heater. This is going to be good for our testing, but also as a fail-safe. We can control the temperature with OctoPrint, but we could set this one just a little bit higher. So it's good to have. So let's say we wanted 40 C in the enclosure, we could set this one to 50, just to make sure it never went over that. But it's going to be good for our tests. Now the heater, it just has tabs on it. We can screw it directly to the enclosure. That'll work. I want to put it in the back corner. Since these are panel mount, I did create a 3D printed adapter. It'll just snap on here, and this will screw down to our enclosure. Now remember, I just said this is 120 volt AC power. Don't do any of this if you're not comfortable hooking up AC. This can be very dangerous. And today I am just using a pigtail. This is some lamp cord, and I'm not going to be concerned with the ground. Now, this is just for the test though. We are going to have to work in a ground here. I'm going to deal with that when we deal with the power supply on the printer. For today's test, this should be just fine. But I can't say it enough, please be careful when you're dealing with anything AC. Don't do anything that I'm going to do if you're not comfortable with it. So our thermostat, basically all it's going to do is break the hot wire. So it'll be in line on the line wire. So on these heaters, they just have a cover that protects you from those terminals. And we want the wires to be long enough so that we can get to our thermostat and our heater. Again, I'm going to put the thermostat in the front left corner and then the heater in the back right. Both at the bottom. Now the bottom for the thermostat is probably not the best location, but we do have that temperature sensor on the top, so we can take measurements of both. So I got my heater back there in the corner, have my 3D printed bracket, that is printed out of ASA by the way, and then the thermostat will just snap into that bracket. Now we can wire it up. So either side on that heater, doesn't really matter what's neutral or what's line, the hot wire. I'm going to take the left terminal over there and run it to the left terminal on my thermostat. Again, it doesn't really matter on the thermostat either. We're just breaking the hot wire so that we can turn it on and off. I am going to put some ferrules on the ends of these wires before we put them underneath that terminal. It's always a good idea. So here's what we got. On our thermostat over here, the right terminal, I have it run to the hot wire on my pigtail, to the plug. And then the left terminal here goes over to the left terminal back there on my heater. That's the hot terminal, and then the right terminal back there on the heater goes to the neutral on my plug. There's currently no ground involved, but just for this test it should be okay. Also, turning it on and off, I'm just going to plug it and unplug it and let the thermostat do the work. Again, we are just in testing mode. So we've got everything cabled, the heater cover is back on. I'm going to create some test prints so we can try out a few different temperature ranges, but I'm just going to go ahead and plug it in now, make sure it's heating up and everything is working as expected. The heater's been running for about 15 minutes or so. The one on the front here, the humidity is going down as that heater runs and dries out the air. We're already up to 35 C. Let's check our OctoPrint sensor, and it looks to be reading about the same. We're setting at 36 C. So we're definitely getting warmer. Now let's set up and run some tests. So let's talk about testing just for a moment. Dave and the crew over at Printed Solid put a lot of work into these enclosures so that you would have a consistent printing environment, but the printer wouldn't get too hot while testing, so you wouldn't cause any damage to it. Now when doing tests like I would like to do, that becomes a problem. And I did two things to combat it. Now remember, there is no printer inside here. That is going to add a lot of heat to your enclosure even if you don't have an actively heated chamber. But since I don't have a printer, I just wanted to test some materials. I did upgrade to the largest heater I can find, a 250 watt. Most of the time you probably would never need that, especially in an enclosure like this. And I have completely wrapped the enclosure, and that's kind of why it looks like a baked potato. I even used some of my floor mats, one on the bottom, one on the back, one on the side, just so I could reach higher temps. And I did get it over 60 C. This was one of the tests I did. I didn't quite make it to 60 when I snapped this picture. I was able to get it just a little bit higher than these readings here, but this is probably more than enough heat to be able to do the test that I want to do. If I wanted to wrap it even tighter, get a little bit more foam, I'm sure I could insulate it and get it even higher, but again, this is probably enough. And here's a look at the part that I came up with for testing. Basically, it's a square spring with two eyelets so I can hang weight from it, and we can see how much it deflects as the enclosure heats. I did PETG from Prussiament, printed solid PLA, and Prussiament ASA. So basically, all I did was I have a hook hanging from the top of the enclosure. There's actually some chain that goes through the top. On that hook, I'm hanging our test part. I use zip ties because that metal hook will actually melt through the print. And then on the bottom of our test part, I'm hanging a 5-pound round weight. And then I did a series of tests. I did a static test, just hanging there, room temperature, so I know it didn't deflect. None of the materials, PLA, PETG, or ASA, did deflect after hours of hanging, so that's good. They probably would long periods of time, but not 10, 12 hours like I tested. After the static test, basically I had a bunch of different test parts. I put them all in here, let the enclosure start to heat, and then I did a time lapse so you can see what temperature it was and when the part started to deflect and how much it did. And the testing is somewhat interesting. Now, this scenario isn't perfect. This isn't going to show you exactly what's going to happen to every part depending on its size at what temperature, but I think it is kind of neat to see it stretch as the heat increases and how that affects different materials. At least as hot as I could get this enclosure. So have a look at the time lapse. And after the time lapse, you can see just how far some of these did deflect. This is a stock part. This is after that time lapse run. Again, printed solid PLA. On the PETG, this is the stock part. This is about midway through the test. I stopped it at around 40°C. And this one is after I let it run quite a while. So the heat in some parts, in some scenarios, is definitely going to affect your print. And then with ASA, the stock part, and after the test. This one ran for a long time, 10 plus hours, and this is the only deflection that you saw. We would have to get it a lot hotter in there to be able to affect ASA and ABS types of filament. And I'm going to say it again, this is a perfect case scenario here. I made this part so that you could see it stretch while the heat increased. That doesn't mean every part is going to be affected the same way, depending on what material it's made of and the part structure. But I wouldn't go very far with a printer that had 3D printed parts on it. I would keep it 45°C or less just to be safe. That's enough temperature for your enclosure to get really nice parts in a lot of different filaments. Now, with all that testing complete, we need to do one more change for this video, and that is, of course, we need to add a webcam so we can monitor our prints. And I came up with this part right here. This is just a modified mount that I use on a lot of my enclosures because it fits the type of Logitech camera that's meant to sit on top of your screen, the kind that just has a little dovetail that goes into here. And on the back side, you can just use some square nuts. There's a tunnel here for the wire, and this will sandwich in the corner of the enclosure, so it's kind of pointing down. You can see I just have it mounted right here. I've got my C270 kind of pointed towards the center of the enclosure. It just slides in there. You can put it as high or as low as you want, depending on your setup. And on the outside, I drilled a fairly large hole and some screw holes so that you could screw it down. Again, there's square nuts inside the part. This is so that the USB cable will pass through here. You could just as easily pull this front part off, just undo the screws, cut a little valley in here, and it would work the same. The part's going to be available if you'd like to rework it. This is just how I went about it, but this part with that tunnel in it fills this hole, so it shouldn't be an issue. But the smaller the holes, the fewer of them you have, the better you're going to be with your enclosure. So there we go. Part 1 of our automated enclosure build is now complete. But we have a lot more to do, and it should all be included in the next episode, which should be out fairly soon. But I did learn a lot from this build. How hot can the enclosure get? What happens to certain types of filament when they get too hot? And that's all valuable information going forward. Now I feel a lot more comfortable putting my Prussian machine inside here that does have a lot of 3D printed parts. We have a lot more stuff to tackle though, like the PSU needs to go on the outside. You don't want that in your heated enclosure. As well as how can we automate the filtering of an enclosure, as well as the cooling and the heating. So we have a lot more to learn. I look forward to sharing that with you. I'll see you really soon on the next video, and now I can finally take all this stuff off this enclosure so it looks halfway decent again. Take care, everyone.